mathematics and literature and cognitive studies. We are honored to have with us tonight Dr. Emerald Princess Sheela, JD, Assistant Professor, Department of Mathematics, Queen Mary's College, Chennai, as a keynote speaker. She will enlighten us with her thoughts on literature and computer mathematics. I also extend a warm welcome to our paper presenter, Ms. Sai Shri R, ma'am, lecturer, Department of Biology, Fullinfaws, PU and Degree College, Bangalore. She will be discussing literature and critical thinking. I extend my warm welcome to faculty members, research scholars, and PG students who are present at this forum. Now I request Ms. Sai Shri ma'am to present her paper.
Who's presenting first? Emerald ma'am, no?
Yeah, I'm ready.
Nancy? Sai, I think Emerald ma'am is presenting first.
Sure, ma'am. Okay.
Okay.
Emerald, you can present. Sir.
Yeah, I can start.
Okay, ma'am.
Good evening to all. I'm so glad to be part of your tandem club today. Hope I'm audible clearly.
Yes.
Okay. Yeah. So the topic given to me today is to connect literature with mathematics, and I'm here to speak about not just the pure mathematics side, but I'm just connecting literature with computer mathematics. And one of the field in computer mathematics is formal languages and automata theory, and they are the fundamental concepts in computer science with applications in various areas such as compiler designing, string processing, networks, and other softwares. Yeah, can just hold on with Noam Chomsky's thing. I'm moving on to him. Yeah. So one of the concept of formal languages originated in the mid 20th century, and with the much significant contributions from the well-known scientist Noam Chomsky. And he introduced the concept of formal languages in his groundbreaking work on linguistics, particularly when he wrote the book Syntactic Structures in the year 1957. So Chomsky's work aimed to provide a structure to the languages, to a formal framework for describing the structure and syntax of natural languages such as English. And he introduced a concept called generative grammars, which has a set of rules for generating all possible sentences in a language while also capturing the underlying structures. So, based on that, he classified the formal languages into several types, and he also gave an hierarchy for them, which is called the Chomsky hierarchy. So, today I'm just going to briefly share how he moved on from the structure of any language, such as English, into the formal languages. Yes, next screen, please. Okay, next screen. Okay. So consider a simple sentence in English. Just consider this sentence. The peacock is a beautiful bird. Okay. So he just takes that sentence and he tries to find the structure of that sentence. So as all of you know, you are all literature people. So this sentence has a noun phrase and a verb phrase. And then that noun phrase can be still broken down into an article and a noun. And the verb phrase, yes, you can continue clicking. The verb phrase breaks down into a verb, article, adjective, and another noun. So then finally you see that the article, first article is the second noun. The noun is peacock, the verb is this, article is a, adjective is beautiful, and the noun is bird. So this structure tells how starting with the simple sentence, okay, the final sentence, the peacock is a beautiful bird, is achieved. Next slide. So now he tries to find the rules from this structure. So if you remember the figure, we started with a sentence, and the sentence led to a noun phrase, a verb phrase. Then the noun phrase led to an article and a noun. Verb phrase led to a verb, article, adjective, and a noun. And the first article led to the word the, noun led to peacock, verb led to is, article led to a, adjective led to beautiful, noun led to bird. So this is how you get the set of rules by breaking down the sentence. Next slide. So now, see, I'm rewriting everything just with letters. So the sentence I denote by S, noun phrase by NP, verb phrase by P, noun by N. So first noun, I call it as noun 1, N1. Second noun, I call it as N2. Adjectives, I call as A1 and A2. So I'm able to rewrite that whole structure using these rules. So when I apply these rules, I will get back that structure. So I'll start from the first one. Yes goes to noun phrase, verb phrase. Then if I follow these rules, you will get the structure which you saw in the first diagram. And that will lead to, starting from yes, you will be able to generate the entire sentence. The peacock is a beautiful bird. Okay, move on to the next slide. Similarly, so this I did for an English sentence. Now the same we are going to see for a Tamil sentence. Move on to the next slide. Okay, so I'm taking the same thing in Tamil. Mayil Indiavin Deshiya Paravai. So now my sentence I start as yes. So it goes to a noun phrase. But if you see here, the structure is a little bit different because the grammar for Tamil is different from the grammar for English. So this is the structure that I get. Can you move the slide little down? Mayil Indiavin Deshiya Paravai will come. Yeah. Indiavin. So if you see here, you get the last starting from yes. Using this structure, I'm able to generate the sentence Mayil Indiavin Deshiya Paravai. Next slide, please. Okay, so now if you see the corresponding rules for this grammar, for this sentence, yes is going to N1, P1. Then my N1 is directly going to the word Mayil. Then NP1 leads to a rule. In that, NP2 has a rule. My N2 has a rule. A has a rule. N3 has a rule. And then you see a case ending there. That is India plus in becomes, that case ending is in. So in Tamil grammar, when I add India plus in, it becomes Indiavin. So that's a difference in the Tamil grammar. So if you see here, the rules are quite different from the rules which you saw in the first one. For example, can you move to the next slide? So I'm just showing you what were the similarities in both and what were the differences in both. So the similarities were yes was the sentence symbol for both. And there were two sets of symbols. If you had noticed well, you had some capital letters which are called the non-terminals, and then the final words which were all running letters. The words are called the terminal set. So the final sentence will have only the terminals. And if you see the first one, the rules were only of the form u going to v. So I write u arrow v, which means u and v are strings over terminals or non-terminals alone. So left side also I had some terminals and non-terminals. Right side also I had some terminals or non-terminals. Whereas when you come to the second one, I had the same type of rules. Okay. But if you see the last one, this was missing in the first one. So on the left hand side, it's a string of terminals and non-terminals. And okay, here you have a case ending coming here on the left hand side. India plus in going to India plus win. So this was the difference I noticed from the English grammar and the Tamil grammar. Yeah, next sentence. Next slide. So based on this, so Noam Chomsky found that there are different ways, different types of rules which can generate different types of languages. Next slide, please. So based on that, he found 4 types of grammars. Okay, yeah, just keep clicking. And 4 types of grammars which generate previous slide, 4 types of languages. So we have the previous slide, please. The regular grammar, which is the smallest one, which is contained in the context free, which is previous slide, please, which is contained in the context sensitive, previous slide, and that is contained in the phrase structured grammar. Next slide. Yeah. Okay. Apart from all these, the main reason for the development in formal grammars is now using these 4 types of grammars. They formed the backbone in the field of theoretical computer science because they were used in most of the formal language, in most of the languages used in computer science, as well as in the compilers, which convert the high level language into the low level language. They make use of such languages. Yes, next slide, please. Okay. Yeah, you can quickly move on. Yeah, this is what I said earlier. So this is called the Chomsky hierarchy of the 4 basic types of languages. Next slide. Okay. So now it was Noam Chomsky who did it in the international area. But here in India, we had Dr. Rani Siromani, who worked in Madras Christian College in Tambram, who worked on these languages and grammars, and she passed away in 2019. She wrote her first paper on grammar of Dravidian number names, and it is published in the Journal of Foundations of Languages. And she and her husband, Dr. Gibbs Siromani, actually she did her research under him. He was the one who started on formal languages, and then they both together did a lot of research and created a lot of formal languages. Next slide, please. Next slide. Okay, so this is Dr. Rani Siromani. She's a theoretical computer scientist with 5 decades of experience in the field of formal languages, and she spent most of her life in Madras Christian College. Yes, next slide. Okay, so now what is formal language? I just want to give you a glimpse of what is formal language. So if you know, any we take that alphabet set, we denote it by sigma. Okay, so suppose I take only 2 alphabets. I can have any number of alphabets. If I take English, I will have the alphabets and set containing A to Z. If I take Tamil, previous slide please. If I take Tamil, there are a different set of alphabets. A, E, Ka, Ka, all those things are there. Okay, now previous slide please. So we start with the basic set called the alphabet set, which I denote by sigma. And the words over, what do I do with the alphabets? Next, I go to words. I call all those words as sigma star. So what is a word? A sequence of all those elements of sigma. So a word can be, suppose I have A1, A2, AK letters, and then I can write a word over A1, A2, AK. Now, once I write a word, in maths, I can find the length of the word, just counting the number of alphabet. And then the language over that alphabet will be using those rules in the grammar, whatever words I can generate using the alphabet, then that becomes the language. Next slide. Okay, so if I have A, B as my alphabet, I can generate words like A, B, any word over A and B I can generate. They're all strings over the alphabet. Now, computer can recognize only zeros and ones. That's why we take mostly a 2-letter alphabet set. So if I take 0 and 1, I can generate any number of words over zeros and ones. It can be length 1, length 2, 3, 4. That's why I have it as an infinite set. So these are the words which will be used by the computers. Yeah, next one. So how he defines a grammar, this was all formed by Noam Chomsky. So the grammar I will define as NTPS. So I have some non-terminals, which I denote by capital letters. The terminal set T, which I will have only terminal symbols. And then P is the important one, which is called the production rules. What are the rules I'm applying to generate the language? And S is called the start symbol. Next slide. Yeah. Next slide, please. So if I say here the rule, I will say the rule U going to V, where the left side U can be over non-terminals and terminals, and the right side V can also be strings over non-terminals and terminals. Next slide. Now I give restrictions on this phrase structure grammar rules, and I get 3 different types of grammars. So the first one is the context sensitive grammar. So the grammar will be defined the same way with NTPS. The only change will be in my production set. Can you move the next slide, please? Yeah. Okay. The next slide. So what I do, I start from this. Okay. So if I here, I start from the S and I derive all words W using the rules of P. Next slide. Next slide. The slide isn't moving. There's some network issue. Can someone else share the screen? Okay, so now context sensitive. So see the difference in the rule. If U comma V is the P, that is, if U goes to V means, you see the last line, the rule will be of this form. Alpha A beta going to alpha gamma beta. That means what? In the context of alpha and beta, if in a word I have alpha beta, in between that, if I have the non-terminal A, then say that A will be rewritten as gamma, provided alpha beta remains on the either side. So you see here, it is very sensitive to the context. So in the context of alpha and beta, my letter A is rewritten as gamma. So because it's sensitive, it is called a context sensitive grammar. The next one, next slide. So you can see an example in the next slide. Sharing is on.
Excuse me, ma'am. 2 minutes, ma'am.
Yeah. Can you go to the slide mode, presentation mode? It's okay, you can share like this itself there. Because I've given animations there. Can you go to the previous one, the example, and you're not able to do the slideshow? Vasanthi ma'am, can you try to share the PPT?
Yeah, shall I try now?
Can Vasanthi ma'am try?
Yeah. Can I?
Yes,
Yeah.
ma'am.
Yes, just a second, please. Have you shared it?
Yeah, I've sent by WhatsApp.
Just check.
Have you got it, ma'am?
Yeah.
Okay.
But I have not yet received from my laptop.
Okay.
Shall I try to share from my mobile?
Okay.
Is it visible now?
No, it's not visible. It says we are not able to share. Okay, Nancy, can you try?
Somebody has shared it.
Nancy, is the net okay?
Yes, ma'am, I'll try now.
Yeah. Yeah. Yes, you can move on to the context sensitive. Bhakti ma'am, I think the one has to be muted.
Yeah, yeah.
Ah.
Yeah, I'm trying.
Okay, can you move to that slide? Context sensitive.
Shall I share now?
No, she has shared.
She has shared.
Ah.
Okay.
Yes, ma'am, you can share, ma'am. It's slow, ma'am.
Okay, I'll try.
Then you have to close, Nancy.
Yeah. Can you?
Okay.
Is the screen visible now?
Yeah, it's played. Ma'am. Ah. So this is what we were seeing. We'll go to the example. Next slide. So if you see here, you keep clicking one by one. Clicking, ma'am. Yeah. So I have this grammar. Yes. You can keep clicking. This is my non-terminals, capital letters, terminals ABC, and these are my production rules. So when I start with the first rule, yes. So yes, you keep clicking them. Yes, we'll go to A's, BC. Then again, I apply the second rule, third rule. You can keep clicking. Okay. So I use production 1, n minus 1 times, I get the word. Then I use production 2, I get a power n, BC, the whole power n. Production 3, yes, keep clicking, ma'am. Okay. Goes on. So finally, I get the word, keep clicking. Yeah. So finally, I get the language A power n, B power n, C power n. That means any number of A's followed by the same number of B's followed by the same number of C's. So if you see the rules here, it is of the type context sensitive. Why I say context sensitive? You see the third rule, only if it is CB, I can rewrite it as BC. So there is a context involved there. Yeah. Next one. Next slide. Next is context-free grammar. If the rule is of the form just A going to alpha, that is A is left side non-terminal and right side I have all words over the variables, terminals or not terminals. Then it is called a context-free grammar. Next slide. So in a context-free language, this is the example. You can keep clicking, ma'am. Yeah. So the production I'm having just two rules, S going to ASB and S going to AB. So I'll start with the first rule, apply it, keep clicking, ma'am. I'll keep generating as many as I want. If I want A square, B square, I'll apply the rules once and stop. If I want it more, I keep applying the rules again and again, and I get the language A power and B power. So if you just see the production, left side is just one terminal, right side can be terminals and non-terminals or just terminals. So this is context-free language. The next language, next slide, regular languages. Yeah, if you see an interesting word generation here, I generate all the palindromes. What is a palindrome in English? You have WW reversal, reversal of the word. So for that, I give this rule. So if I use these rules, then I generate all the palindromic words.
Can I give an example of a palindrome?
Yeah, yes.
See, able was I, ere I saw Elba. So you can read it the other way.
Yeah.
This is for my students.
Right.
Able was I, ere I saw Elba. So that Elba and able, you can read it backwards. So that's a palindrome, students.
Yeah. So if you see here, so AA is a palindrome, A and reversal of A, BB. Then if I have AB, then I have BA. Then if I have AA, BA, again if I, so I'm able to generate palindromic words using context-free grammar. There we had left side non-terminal, right side can be any number of terminals, non-terminals for context-free. But for a regular, it's very limited. Left side is non-terminal, right? You should have just one terminal and one non-terminal or just one terminal. If the rule is if this form, then it is called a regular grammar. And the language is a regular set. Next slide. So an example. Yes, you can keep clicking. See the rules, it's of the regular form. Then the words generated are AB, AAB. Yeah, next. Click, man. Yeah, keep clicking. Okay, can click. Yeah. Next slide. Maybe you go to the next slide. Next. Next slide. Yeah. We keep moving. So the final language is A power n. Earlier, you remember using context sensitive, I had A power n, B power n, equal number of A's and B's languages. Here I have A power n, B power m. I can have unequal numbers of A's and B's. Of this can be regular cannot generate A power n, B power n. Regular can generate only A power n, B power m. Such types of words. Yeah, next slide. Okay, next slide. Okay, I can move on to the next. Okay, so if you see from these definitions, there is a containment. The largest is the first definition, phrase structured language. So that will contain context sensitive languages, which in turn will contain context free languages, which in turn will contain regular sets. Next slide. That's how Chomsky came up with this hierarchy of languages. Regular is the smallest, contained in context free, contained in context sensitive, contained in unrestricted grammars. Yeah. Next slide. Yeah. So now from there, these are, you have a pattern variable and you can move on to the next slide. And then you have an axiom word. So in the pattern variable, I will substitute the axiom word. Can you move on to the example? Next slide. Okay. So I represent it by G equal to sigma delta AP. Okay. Where sigma is the alphabet and P is the pattern, finite set of patterns. pattern. So it will have a pattern variable. So in that variable, I will substitute the axiom and keep substituting all the words which are generated. So I get a set of pattern words. And you can move on to the next slide. This is the definition. You don't need that. You can move on to the next slide. Yes, the next slide also. So all words generated up. So, okay, see here, the axiom is next slide. I take my axiom as just one letter A. Okay, and my pattern is C delta D. I'll substitute my axiom in delta. So my first word will be in C delta D, I substitute A for delta. So I get CAD. That is one word. Then every word generated, I will again substitute back in my pattern word. So I substitute CAD in C delta D. I get the next word C square A D square. So like that, if you keep substituting the words which I get once again back in my pattern. Yes, next one. I get a set of words like this, which will follow a pattern. So I'm getting a pattern as a list of C's and A and the same number of D's. So such words are called pattern words, and this is called as a pattern language. Next slide. Yeah. So if you see the application of these pattern languages, so if I take this grammar, which is a pattern grammar, and I apply it in biology, so I'm having only two letters A and B. I call A I cell. Then my pattern is generating like this. No, cells keep growing, isn't it, in our body? So I can model the cell growth in biology using such pattern languages. Yeah. Next slide. Yeah. Now, again, this is another example which also gives a set of pattern languages. So when I apply that, I get how the cells get multiplied. Cell division happens here. So two cells again divides because of
of consciousness. For him, literature replicates a mental process of recoding. To me, thinking critically means seeking out different viewpoints before I form my own. Getting out to hear and see for myself instead of watching TV or Googling at home. Seriously, I believe the foundation to thinking critically lies in our ability to look at things from multiple angles and perspectives, to explore for more truth and opportunity, to find solutions for problems with great complexity. Why, oh, why does humanity not take to think critically? I blame our human nature for the failure. I think it's easier to be spoon fed and led to a conclusion instead of expending the energy and time to think ourselves. To me, critical thinking is about activity, not being passively spoon fed by the internet or TV. It's learning to weigh, think, and solve problems for yourself, not having to rely on someone else to tell you what to do, believe, or say. Thank you.
Thank you, Sai.
Yeah, it is so good. You
Thank you,
capped
ma'am.
it with that. Yeah, you capped it with Lee Thomas's poem, which said everything.
Any questions for Sai? Any observations?
Yeah, that's why I said she capped it with her last
Hmm.
poem, Lee Thomas's poem. I think it said everything. Yes. No literature is born, no, except if people thought, I mean, unless people thought differently.
Shall we close the session then?
Yes.
If nobody else is. That was a brilliant paper, Sai. Thank you so much.
Thank you, ma'am.
Kalpana, we can close.
Oh, yes, ma'am. As we draw the session to a close, I deem it an honor to propose the vote of thanks. I thank our keynote speaker, Dr. Emerald Princess Sheela, sharing her valuable insight. And I also thank our paper presenter of today's session. I thank our college principal for her constant support. Special thanks to my diligent HOD of English department, Dr. Maria Preeti ma'am, for her visionary leadership, and to our tutor, Dr. Vinita Francis ma'am, for her dedication and and research scholars who are present at this forum. Once again, to all our attendees, thank you for your active participation for making today's session success. We look forward to seeing you again soon for our next event. Thank you all.
Thank you, Emerald.
Thank you.
Yeah,
Thank you.
thank you so
Thank you.
much.
Thank you for the opportunity. Thank you.
Yes.
We learned a lot. Thank you. It'll take us some time to actually, put the connections down, but we are getting initiated into this.
I had to
Thank
go
you.
fast because the presentation took,
Yeah.
I couldn't share
Yeah.
my PPT. That was a drawback For me.
Mm.
It was
No,
clear.
no, it was clear. It was clear. It was clear.
Okay.
A few hitches in the
Yeah,
to start to begin with.
yes.
It was clear.
Okay, okay.
We understood. We understood, and